So now today we'll discuss about the new chapter which is known as gravitation. Since ancient times, scientists were very interested to know the mysteries of stars and planets. Famous astronomers like Johannes Kepler observed the motion of stars and planets for many years and made tremendous contribution about their motions. Kepler, so here we know about Kepler. So Kepler first realized that planets move around the sun because of the action of a force, but he was not sure about the nature of the force. In 1681, Sir Isaac Newton, so in 1681, Sir Isaac Newton, so in 1681, Sir Isaac Newton first solved the problem by discovering the law of gravitation. So, uh, Newton says that there exists a force of attraction. So he says that there exists a force of attraction, a force of attraction, a force of attraction between two bodies or particles of the universe, two between two bodies and particle of the universe. This force of attraction is sometimes called gravitation and sometimes called gravity. So we have to know what is gravitation and what is gravitation. Please give me some time. And another one is gravity. So what is gravitation? So gravitation says that the force of attraction between two objects or particles in the universe is called gravitation. So it is the force of attraction of attraction force of attraction between two objects or particles in the universe. So this is the main point. This is our main point, which is universe. Okay, universe. Okay, and what is gravity? Gravity says that the force of attraction between the earth and any other object. So it is the force of attraction between earth and any other object. So this is known as the gravitation is the force of attraction between two particles in the universe. So everything in the universe has force of attraction. This is known as gravitation. But gravity says that it is the force of attraction between earth and any other object. So between these two objects, one object should be earth, then we should call this as gravity. So suppose the attraction between sun and moon is known as gravitation, whereas the attraction between earth and moon is known as gravity. Okay, I hope you clear these 2 points, gravitation and gravity. So now let us talk about Newton's law of gravity. So it says that the law states that every particle in the universe attracts. So this is an attraction force. So we can say that gravitation is an attraction force. So it says the law states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses, and inversely proportional to the square of the distance. And this force acts along the line joining two particles. So this is 2 3 point. Now we break down this whole statement. So it says that the every particle in the universe attracts every other particle with a force. So suppose we take this force as F, and this F is proportional. It is proportional to the product of their masses. Suppose this is an object M1 and this is an object M2, which has a mass of M1 and M2. And these two particles will attract due to the gravitational force. So these two particles will attract each other with a force of gravitation. Okay. So this force F is proportional to the mass of product of their masses. So the product of their masses means M1 into M2. So this force F is proportional to the product of their masses, and says that it is inversely proportional to the square of the distance. Suppose this distance, the two objects has a distance d, then it says that this force will inversely proportional to the square of their distance, and this force acts along the line joining the two particles. So this force will act the line joining to the two particles, to this line. So okay, now we derived an equation from these two information. So we can write this two information like this. So we can write F is proportional to the M1 M2 by d square. We are joining these two information. Now here we find a proportional sign. To remove this proportional sign, we have to use a constant. We have to use a constant. So we use the constant G. We use the constant G, and this G is known as gravitational constant. It is known as gravitational constant. Gravitational constant. So and the value of this G is 6.67 into 10 inverse 11 Newton meter square kg inverse 2. So this is the value of this gravitational constant. We find this gravitational constant by some experimental value. So we shouldn't go the how we find this value G. You have to remember the value of G, which is 6.67 in 10 inverse 11. So this is a very small value. This is a very small value. That's why when two objects attracts each other, they doesn't collide with each other, because the force that acts, the gravitational force acts between these two objects are not very big. There is a small value. So this is known as gravitation, and gravitation is very important because by the help of this we derive many equations. We know the laws of nature. So we have to remember this equation, the final equation, by deriving Newton's laws of gravitation. Okay, now we'll see some universality of Newton's law of gravitation. So it is said that Newton's law of gravitation is applicable to all bodies. So it is applicable to all bodies like atomic particles, to large planets or body. Large planets or body. Okay, so this is applicable for atomic all bodies. Then it says that it is valid over a wide range of distance, from the small terrestrial distance to the long astronomical distance of the space. So this is valid over wide range of distance. So, and the third point is it depends only the masses of the bodies, not any other properties of the bodies, like whether it is solid, liquid, or or gas It doesn't depend on these three. Okay, it only depends on the masses of the body. The fourth one is it doesn't depend on the medium in which particles or bodies are situated. So it doesn't depend on the medium. Okay, it the gravitational force the value of the G is constant over the vacuum medium or the air medium or the water medium. So it doesn't depend on the medium. Then the next one is it doesn't depend on the temperature, magnetic field, pressure, or any other physical condition. So it doesn't depend on this any other properties like temperature, magnetic field, pressure, or any other physical condition. G is an universal constant. The value of G is an universal constant. Gravitational constant is an universal constant, and its value is 6.67 10 inverse 11 Newton meter square kg per meter. This is the unit of this value G. Okay, so this is all about universalities of Newton's law of gravitation. Now coming to the next one, we have to find out the acceleration due to gravity. Acceleration due to gravity. We in our previous lecture we always use the value of G, the gravity acceleration of gravity. But how we find out this thing? So we have to first remember this thing. And what is gravity? Gravity is something that between the force of attraction, the two products, between these two products, one product must be Earth. So for the definition of gravity, one product or oh sorry, not one product, one object or particle, one object or particle must be Earth. So suppose this is Earth, okay, and here is an object M. Here is an object M. So we have to find out the attraction between these two force. So by the formula of gravity, suppose we have to mention some points. Suppose this is the Earth and the mass of this Earth is capital M, and this is an object which has a mass small m, and the distance between these two is suppose this object is on the surface of the mass of the Earth, surface of the Earth. Okay, so the distance between the surface of the Earth and the project and the center is this, which is the radius of our Earth. Okay, so this is the distance between this object and our center of our what should I say, Earth, center of our Earth. Okay, so by the law of Newton's gravitation force, we can say that this force F is equals to the G, product of these two mass. So mass capital M and small m. This is the mass of capital M represent the mass of the Earth and small m represent the mass of the object, and the distance between the square distance between the two objects. So the square distance is the radius of our Earth. So this is the gravitation force according to the Newton's law of gravitation. Okay, so we find out this thing. And from the Newton's second law of motion, we know force equals to the mass into acceleration. Here mass means the object, mass of this object, and acceleration, we represent this acceleration as G. So by these two, if we connect these two forces, because this force and this force are similar, so by the help of these two, we can find out the equation which is known as G mm by r square equals to mg. Okay, if we count these 2 points, because we have to remove this m from both of the side, we find out G equals to gm by r square. So from this, we find out that our gravitational acceleration is only depend on the distance between these two objects. between the object and the earth, because this gravitation is a constant value. Gravitation constant is a constant value, and this mass of the earth is also a constant value. So our g only depends on the distance between the object and the center of the earth. So we can say that the acceleration due to gravity at a place is inversely proportional to the square of the radius of the earth, or the distance from the center of the earth. Okay, so this is our main concept of acceleration due to gravity. We have to only remember this equation: g equals to gm by r square. Uh, this g is actually this g is actually varies from different place, because the value of the g is varies from different place, because our because of some four criteria, because of four criteria. One is variation. So we can say that variation variation of gravity. So variation of gravity is happen due to due to altitude of the place. Altitude of the place. The second point is non spherical non spherical non spherical shape of the earth. The third one is rotational motion of the earth. And the fourth one is non-uniform density of the earth. The non-uniform density of the earth. Okay, we'll discuss this four point in our next lectures. That's all for today's video. Hope you understand the basic concept of gravitation and gravity, and the Newton's law of gravitation and acceleration due to gravity. So please do subscribe to our channel and like this video. Thank you.